Hello, and welcome to your fifth grade weekly preview for math content over the week of October 10th. I'm Sherry Height, and my information will be on the last slide, so if you have any questions, feel free to contact me at any time. All right, so let's get in and talk about DCP data. We would really like to help you figure out how to get the biggest bang for your buck when it comes to reteaching and spiraling back in TEKs that you've already taught that were on your DCP. So we're going to talk about a few different things. Let's start with talking about frequency. Okay, to get the biggest bang for your buck, you need to look at which TEKs are frequently tested on STAR. And so we can do that by looking at our frequency distribution chart from Lead Forward. This chart shows you a few of the TEKs that you had on the DCP from this last test. And so 5-2B, if you look at it, we have 2 questions on every test were over 5-2B for a total of 10 questions in the last 5 years, okay? That's quite a bit of TEKs, and that is one of your decimal TEKs. Compare that to 5-2A, another one of your decimal TEKs in 5th grade, where it's only been tested twice. It's only tested about every other year and only one time. So if we were looking at these 2 TEKs, which one would be a bigger priority or give us a bigger bang for our buck to put in our spiraling review? Right, 5-2B, of course. So that might be a whole class reteach, just depending on the situation. Now let's look at 5-3K. So 5-3K is add and subtract positive rational numbers fluently. Now, this again shows that this TEK has been tested 2 times every year for a total of 10 items in the last 5 years. However, this TEK has positive rational numbers. So what we've taught so far is adding and subtracting whole numbers and decimals. Later on in the year, we'll teach the same thing, adding and subtracting with fractions. And so basically what happens is every year it's tested once with whole numbers and or decimals and once with fractions. And so we can see that it will for sure be tested using what we just taught with adding and subtracting decimals, if that makes sense. So that one, yeah, frequency, for sure, looks like that one's going to give us a bang for our buck, right? Now look at 5-3C. Even though 5-3C is a supporting standard, which means it's tested 0 to 1 time every year, look at how many years it has been tested once. 4 times in the last 5 years. So that tells me if that is an easier TEK, I would go ahead and go after that one, because it is tested almost every year. Sometimes those supporting standards, the yellow ones that are only tested 0 to 1 time each year, are a little bit easier. 5-3C is going to be easier than the 1-step and 2-step of 5-3K, and it's tested almost every year. So actually, I'd go after both of those. Okay, but that's only one thing we look at. We definitely want to look at frequency, but we also want to look at time to mastery. And so that depends on the standard. Look at the predictability of the questions. If there is a way that the questions have been asked consistently that look the same, those are things we're going to go after, and we're going to go after them in that way. For example, if you see that in 3 of the 5 years or 4 of the 5 years, they have added or subtracted decimals where they use a whole number with no decimal and no trailing zeros, and then they use some decimals, and their 2-step, the way they're asked in the 2-step, if that is predictable, that's an easy go after. Because if it's always asked with money and getting change, or if it does that a lot, then maybe that's one that we go after, and we go after that type of question within 5-3K, okay? Same thing for 5-2B and 5-2A. If they go after representing decimals and expanded notation and is asked the same way every time, then the time to mastery is going to be a little faster because we know how they're going to ask it, or we can predict that they're probably going to ask it in this way. So we can get our students to master that TEK more quickly. Now, if there is a TEK that is asked in a different way, completely different every single year or every single time it's tested, and it's not tested very frequently, then that's a TEK that I wouldn't go after in my acceleration or in my whole class reteach, or really probably even in my spiral review. So for the last piece of this, looking at your DCP data, we also want to look at low level of difficulty. We're not going to look at the lowest performing TEKs. And I know that seems counterintuitive. Usually we like look and we go, oh, we're really low in this. We've got to reteach this and do this. But that's not what we're asking you to do here. We want you to look at your underperforming TEKs instead. Now, what underperforming means is, let's say that the district as a whole or the state as a whole is at 83% on a particular TEK. But on our DCP data, we're at 60%. Okay, that shows me that they can do it, but we're underperforming as opposed to the rest of our district. So that is a TEK where it's not really, really low, but everyone else is higher than us. So let's go ahead and go after that one. There's something that we maybe haven't done in our teach piece or a different way to teach it that we can help students master that quickly. We've already got 60%. So let's see if we can go after the rest of our students on that underperforming TEK. Now, on the other hand, if we look at a TEK and we see that usually on STAR, the state is in the 30s or 40s, and on our DCP, the district is in the 30s or 40s, and we, as a school, are in our 30s or 40s, that's a low-performing TEK, which means it's really hard. It has a high level of difficulty. We're not going to go after that. Why, you might ask? Well, if we're going after TEKs that are frequent, we can predict how they're going to be tested, and they have a lower level of difficulty, then we can get our students to master many of those types of TEKs, whereas it might take us the same number of weeks to get them to master just one high level of difficulty TEK. And so I hope that starts to make sense to you so that when you have your DAT chats at your schools, you can say, I'm not going after this 20% TEK. I'm not going after this 30% TEK because it's not tested very often and it's got a high level of difficulty. I'm going to go after this 60% TEK because it looks like we're underperforming as far as the district, and it's tested every year, and man, it's tested in the same way much of the time. So that's a TEK that I'm going to go after. I hope that that makes sense, but if it doesn't, you can always reach out to me or even Ryan Castle, our K through 12 math coordinator. Either one of us would be happy to come out and look at your data with you and help you decide which TEKs that you're going to reteach. Now, one of the great things is we want you to keep going with the curriculum. We don't want you to stop and spend like 4 days on your underperforming TEKs. Instead, what a great idea would be is to put that TEK in your problem-solving block. For example, 5-3K is adding and subtracting whole numbers and decimals. Put those types of questions in your problem-solving block each day for 2 or 3 weeks until your students really get that type of question, okay? Also, you can put things in your spiraling review. Let's say you're going after expanded notation. If that's a TEK that you're going after, well, let's put it in your Give Me 5. You will notice that after the DCPs, we have a template in curriculum for you, but it's up to you to now choose what you want your Give Me 5 to be. These are usually skill-based, very quick. This is a great place to put your frequent, low level of difficulty TEKs that are skill-based all right here so that you can practice those in your spiral review. Because remember, this year, DCPs are going to be a little bit different, aren't they? We're going to add a few of our underperforming TEKs to our DCP2. So this is really important, and I'm super excited about it because now we'll be able to show growth. Let's say that readiness TEK of 5.2b you were underperforming on. Well, now you put it in your spiral review or you put it in your daily problem solving, and hopefully we will see some growth when we take DCP2 on that 5.2b. So if you have any questions, please feel free to reach out to us. We would be more than happy to help. Okay, this week is a short week. We have 2 days of fall break, and we also gave you 2 flex days for COGAT testing. I was at a campus yesterday, and I noticed that they were being trained for COGAT. And so I'm not certain if COGAT is going to take 2 days or 3 days out of your math lesson. The good news is that this lesson can be taught this week, or we have a space for it the following week as well. And so this TEK is a continuation of representing multiplication. Remember, representing, not solving, representing multiplication of decimals with products to the hundredths using objects and pictorial models, including area models. So far we've taught where we represent multiplying a whole number and a decimal. And we've taught representing multiplying a decimal by a decimal. In this lesson, we're going to go beyond that. We are actually going to look at representing multiplying a whole number and a decimal by another whole number and a decimal. So this is a disclaimer for this, however. If you have noticed in your IQ released items, and I hope that you have, we looked at a few last week and we'll look at a few on this video later, it's never been tested that way. It's never been tested where you have to represent multiplication of a whole number and a decimal by a whole number and a decimal. However, the way the TEK reads, it could be, okay? So that's why we're putting it in here for 1 day, either this week or the next week, whichever you choose, wherever it fits the best. And so, but we want you to know, we want you to know that we don't want you to pull your hair out over it because it has never been tested this way. We want to show it to the students and have them practice it just a little, like 10, 15 minutes. And then we're going to move on and we're going to go back to practicing more with whole numbers and decimals and decimals and decimals, representing it that way, because that's how it's been tested every year, okay? We do want to show it to them because we're not sure with the TEK, even after looking at supporting information from TEA, even after looking at the field guide, it's not clear. Now, Nancy is the one who showed us, Nancy Crouch from Lead Forward, she's the one who showed us this lesson on representing a whole number and a decimal by a whole number and a decimal. But in her field guide, she does not show this. And so I think Nancy is on the same page as we are. We're going to make sure and teach the entire TEK because that's what we're called to do. But we're not going to focus heavily on this part of the TEK because it's never been tested that way. So that being said, I would like to show you a short video that just kind of tells you how to teach this. Now, this may blow your mind because most of us were just taught how to multiply, not how to represent this, right? This goes back to conceptual understanding, and I really like how she uses the area model with whole numbers at the beginning of her video to help students understand what we're going to be doing with the area model here with a whole number and a decimal multiplied by a whole number and a decimal. So it's really smart the way she does it. Hold on to your hats. This is in curriculum, and that way if you have to rewind and pause, it is of course on your Google slide, usually slide 2, okay? So let's watch and see how this is taught.
Hi everyone, today we're going to be taking a look at creating an array using base 10 blocks for multiplying decimals. In previous grades, students have learned place value of decimals. They should also have this background knowledge from addition and subtraction of decimals, which are the skills that come right before multiplication. Just to review, let's remember that the ones place value is represented by a flat, the tenths place value is represented by a rod, which is 1/10 the value of a flat, and the hundredths place value is represented by a unit, which is 1/10 the value of a rod and 1/100th the value of a flat. It might also be beneficial to build an array with whole numbers first to reinforce that when you're finding the total area of the array, you're multiplying the length times the width. Also, that you're reinforcing the fact that you count the corner tile twice. For instance, in this example, I created an array that is 4 square units by 3 square units for a total square units of 12. When I count the units in order to label the sides, I count this corner square twice. I found that this was beneficial to show the students so that as they're creating their decimal arrays, they understand that the corner is counted twice. Okay, here's the decimal example. Jenny is buying a rug that is 1 3/10 yards by 2 2/10 yards. How large is the rug? You'll want to make sure that students understand that the length of the side of the flat is what represents 1, and the length of the side of a rod is what represents 1/10. I'm going to go ahead and build my 1 3/10 yards first. It doesn't matter which way you build your array, but I line them up. This side represents 1 3/10. Remembering that this flat is represented twice, for 2 2/10 yards, I'm only going to add one more flat and 2/10 to show 2 2/10. An array is a complete rectangle, so I will complete the rest by filling in with 3 more tenths and 6 hundredths. In order to determine my total for this array, I'll count up all of my manipulatives. I have 6 hundredths, 8 tenths, and 2 wholes, for a total of 2 86 hundredths. Depending on the size.
Okay, so you start to see that after you build the 1 3/10 and the 2 2/10, you fill in the rest of the rectangle with however many rods and units you need, and then you count them all to find your product. She started in the hundredths place in counting just in case she had to regroup, because sometimes you will have to regroup in this scenario.
Hi, everyone.
Okay, so one way that we are going to look at this is we are going to have a journal page that starts with estimation, and this will help us when we get to the actual multiplication in the standard algorithm as well, because the first thing we're going to do when we multiply a whole number and a decimal and a whole number and a decimal is we're going to estimate a reasonable solution. Okay? Step 2 is we're going to identify the length and the width, so 2 1/10 and 1 3/10, and we're going to represent the length using base 10 blocks. Okay? Then represent the width using base 10 blocks. Then we'll create a rectangular array by filling in the missing area with base 10 blocks. Determine the area is step 6 of the rectangular array by counting the total number of base 10 blocks. Then compare your solution to your answer. Is your solution reasonable? Okay, so first thing we're going to do is we're going to estimate. Well, this is a pretty easy estimation. 2.1, 2 1/10 rounds to 2, doesn't it? 1 3/10 rounds to 1. So 2 times 1 equals 2. Our answer, if it's reasonable, should be close to the whole number 2. So let's start by identifying the length, 2 1/10. So we build that, correct? Then remember, we're going to count this square right here when we do the width as well. So we already have one whole, and we're going to add 3/10. What's our next step? Create a rectangular array by filling in the missing area with base 10 blocks. So that's all we're going to do, is we're going to look at this area right here, and we've got to fill it in. And what is cool is we can see that the 10 rods are going to fit perfectly right here. But then we're also going to have 3 little units. So now what is our next step? We count all of the blocks, okay? And then that'll give us our answer, and hopefully our answer will be close to the whole number of 2. So if we count our base 10 blocks, she started counting at the hundredths, remember? So we have 3 hundredths. We have 1, 2, 3, 4, 5, 6, 7 tenths, and we have 2 wholes. So was our answer reasonable? Pretty close, right? So that is how we are going to teach it. And we're going to practice that doing a few examples with the base 10 blocks. I think the students will really think this is fun, but the really, really important piece that's going to help them so much in the coming weeks is going to be estimating a reasonable solution and then comparing that estimate to their answer to see if it was reasonable. Okay, so remember, if that is a struggle for your students, it's never been tested that way. Here is how it has been tested once again, just to refresh your minds. We have had where George bought 3 peppers for a cost of 40 cents each. And the model represents this situation. We see we have 3 groups with 40 cents in each. And so which one of these answer choices is close to our answer? We have to be careful that we don't get into whole numbers. Like, that's not what we're multiplying both by. We've got 40 cents. So you can see how that would be a little confusing. 3 times 40, that's kind of back to 3rd grade. And again, is this going to be close to our estimate? If we're thinking 40 cents 3 times, well, our answer should be smaller than 3, right? Because that's less than 3 one time. Okay, so 12 and 120 don't make sense right at the beginning. Okay, and so then we have 3 times 40 cents and 3 times 40 cents. But the way we find our answer is to come up here and count. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's a whole. And 10, 20 cents. So $1.20 seems to be our answer. Remember, STAR will always show you what the whole is. Okay, so look at this one. Here we go. This time the whole is the rod. Okay, so the question is, which model represents 1 and 8 tenths times 4, or 1 and 8 tenths 4 times? Okay, we talked about this one a little bit last week. So here we have 1 and 8 tenths, 1, 2, 3, 4 times. Okay, so that's the end of our weekly look at what's coming up for the week of October 10th. If you have any questions at all, my name is Sherry Height. Here is my email, and my extension is 28705. If you have any questions ever, feel free to give me a call, send me an email. I'm happy to come out and look at data with you. I'm happy to come out and plan with you, or look at how are we going to spiral these teaks back in. Happy to help in any way. So give me a call if you need that support. And then, as always, please fill out this survey using the link or the QR code to the left. If you have questions, this is a great place to ask questions. You can also send those questions to my email. Thank you so much for joining our weekly preview.